let's learn the process of glycolysis that involves two main phases. The first one is called as preparatory phase, which usually begins with a glucose molecule. You can see this a glucose molecule. Now that is the starting molecule for the process of glycolysis. This molecule undergoes phosphorylation. That would mean a phosphate group is attached to it. Obviously, in this process, the phosphate is derived from an ATP molecule. That means now ATP would get converted to ADP by giving out a phosphate group which is required for phosphorylation of glucose molecule. This time the enzyme is hexokinase. Hexokinase is the enzyme which undertakes this phosphorylation of glucose molecule. So after phosphorylation, that is after addition of phosphate, now glucose molecule is converted into glucose 6-phosphate. That is, the phosphate group is attached to the 6th carbon atom here. Glucose 6-phosphate it becomes. That is after the action of hexokinase and after ATP is giving out a phosphate group to become ADP. In the next stage, glucose 6-phosphate is isomerized into fructose 6-phosphate. This is a fructose molecule. In the 6th carbon position, a phosphate group is attached. So it is an isomerization of glucose 6-phosphate into fructose 6-phosphate. This involves an enzyme called phosphohexose isomerase. That is a 6-carbon compound being isomerized into fructose 6-phosphate. Now this fructose 6-phosphate would once again be converted, it once again would be phosphorylated. Again, an ATP molecule would become ADP so as to give out a phosphate group which would be bonded to the first carbon. That is, it will now become fructose 1,6-diphosphate or fructose 1,6-biphosphate. So it is fructose 1,6-diphosphate. As could be seen, there is a phosphate group in the 6th carbon position, there is a phosphate group in the 1st carbon position. So fructose 1,6-diphosphate, that is the product of phosphorylation of fructose 6-phosphate. Again, here the enzyme is phosphofructokinase. That is, that's the enzyme which converts fructose 6-phosphate into fructose 1,6-biphosphate. Now, fructose 1,6-biphosphate is subjected to the action of an enzyme aldolase, which breaks this molecule into two halves. This part of the molecule will be separated, this part of the molecule will be separated, and it will be made into dihydroxyacetone phosphate and phosphoglyceraldehyde. This becomes 3-phosphoglyceraldehyde because the phosphate group is in the 3rd carbon position. So 3-phosphoglyceraldehyde and dihydroxyacetone phosphate are the two products of. Now, dihydroxyacetone phosphate can be converted into phosphoglyceraldehyde. Triose phosphate isomerase would be the enzyme. which will convert dihydroxyacetone phosphate into phosphoglyceraldehyde, 3-phosphoglyceraldehyde. So at the end of preparatory phase, there would be 2 molecules of 3-phosphoglyceraldehyde. So this is the end product of preparatory phase, that is 3-phosphoglyceraldehyde, which is now subjected to the process of phosphorylation and oxidation. That is, one hydrogen is removed and it is phosphorylated further. This happens in the presence of glyceraldehyde 3-phosphate dehydrogenase. In this process, a coenzyme called NAD, nicotinamide adenine dinucleotide, would accept that hydrogen and would become NADH2. Whereas the end product of this process, this phosphorylation process, is 1,3-diphosphoglycerate. That is, 2 phosphate groups are bonded to the existing molecule. So, in this process, the end product is 1,3-diphosphoglycerate. That is, in the first carbon position and the third carbon position, there is a phosphate group attached. So, 1,3-diphosphoglycerate is the end product of phosphorylation and oxidation. Now, this 1,3-diphosphoglycerate is subjected to the action of phosphoglycerate kinase, wherein the newly attached phosphate group is detached in the first carbon position, while in the third carbon position it remains as it is. And this time the phosphate removed is picked up by one ADP molecule, so that it becomes one ATP. The product of this reaction is 3-phosphoglycerate, that is, glycerate with phosphate in the third carbon position. This molecule is subjected to the action of phosphoglycerate mutase, wherein just the position of phosphate group is shifted from the third carbon to the second carbon. Phosphoglycerate mutase is the enzyme. And now it becomes 2-phosphoglycerate. That is, the position of phosphate group is shifted from the third carbon to the second carbon. It was here earlier, now shifted to the second carbon. This becomes 2-phosphoglycerate or 2-phosphoglyceric acid. This 2-phosphoglycerate is subject to the action of enzyme enolase, and it's converted into phosphoenol pyruvate or phosphoenol pyruvic acid. The enzyme is enolase. Phosphoenol pyruvate or phosphoenol pyruvic acid is subjected to the action of pyruvate kinase. Now this is dephosphorylation, that is, the phosphate group is removed from it. Quite obviously, this is taken up by an ADP which gets converted to ATP. That is, the phosphate is picked up by ADP. Now the end product here happens to be pyruvic acid or pyruvate. This is the end product of payoff phase, or this is the end product of glycolytic pathway. So glycolytic pathway would start with glucose or fructose and would end finally into pyruvate. If we look at the series of reactions that have taken place, you can see there are two places where ATP is getting converted to ADP. That is, two ATPs are consumed. But in the payoff phase, there are two positions where ADPs are converted to ATP, and every time there will be 2 ADP converted to 2 ATP. So there will be 4 ATPs generated there. Another thing is, when we talk about the reaction of dehydrogenation, that is NAD accepting the hydrogen and getting converted to hydrogenated NAD, NADH2, it sets a series of reactions which result into liberation of 3 molecules of ATP. Now mind well, there are 2 sets of these reactions because payoff phase begins with 2 molecules of phosphoglycerate. So there will be 2 NAD converted to 2 NADH2, which would mean there would be liberation of 6 molecules of ATP. So overall glycolytic pathway, if we consider, we get to understand that there are 10 ATPs generated and 2 ATPs consumed. So the net gain would be 8 molecules of ATP in the glycolytic pathway.